Hello, everyone. Let's talk about the connection between climate and sustainable design. We'll start out with a little bit of information. What exactly is climate? And then make sure to draw that connection between climate, building energy use, and global warming. Finally, we'll touch on how can our architecture, how can our buildings respond to the climate? We'll take a look at the difference between passive techniques and active techniques. Climate can be simply defined as the average weather for a particular location. And there's a famous quote by Mark Twain that says, "Everybody talks about the weather, but nobody does anything about it." But we now know that he's wrong. Humans can, in fact, change the climate, and we are doing it actively and making it worse. If you want to delve into the science side of this, climate is primarily a function of the sun and how the Earth rotates as it travels around the sun. So the atmosphere is heated by contact with the ground, which is heated by the sun. All right. And then because we've got differences between the equator and the poles, differences in temperature, you get some convection currents in the atmosphere. And finally, as the Earth turns, the rotation of the Earth is going to kind of swirl that air around and create some more currents. And we can talk about climate on several different levels. First of all, you can talk about it in a broad band, all right, and talk about tropic, temperate, or Arctic regions of the Earth. You can narrow it down to climate regions or zones, and those are generally regional guidelines. You can go even smaller and talk about a microclimate, which is all about the local conditions, perhaps of the city. And then you can narrow it all the way down to the climate of your particular site and the specifics of that building location. So going back to Mark Twain, his other famous quote here, "The coldest winter I ever spent was a summer in San Francisco." Let's take a San Francisco example. When we're on the global perspective, all right, San Francisco is in a temperate climate. If you narrow it down to climate regions or zones, it can be defined as US Climate Region 6, which is coastal and mild. You can talk about the microclimate and local conditions. San Francisco is famous for its summer fog, but other areas, even in the same region of California, don't have that same microclimate. And finally, you could narrow it down to your specific building site. Perhaps you are trying to build on a steep south-facing slope. When you're trying to research the climatic conditions for a particular project, you'll probably look at some climate data. That could start with just a description of the basic climatic condition of that region or area. And that's kind of shown in this example here. The blue arrow is talking about the climate of this particular example, has a reference city of Hartford, Connecticut. All right. Um, and you also might look into the design priorities of that particular climate and might look at a bioclimatic chart. And that's shown here. Here's some design priorities. It says the number one priority for this region is to keep heat in and cold temperatures out during the winter. All right. And here's a bioclimatic chart illustrating the conditions in this particular location. If you've taken that environmental systems class here at HAC, the Architecture 251, this bioclimatic chart should look pretty familiar to you. All right. If not, you maybe want to go take that class. Other climate data you might look at for a particular site includes temperature, there's a chart right here, relative humidity, and wind speed for the general region in which you're at. Okay. Sunshine, how much sun does your site get? and finally the heating and cooling degree days. All of this data can inform your architectural design. So why are we talking about climate data here in our sustainable design course at this point in the semester? Well, let's tie it back to way back a couple of weeks ago. Remember this particular slide where we talked about how, as architects, we have a large impact on the world around us because buildings use a significant amount of energy and resources. And let's take a look at this chart right here. They create a significant amount of CO2 emissions. Those are those greenhouse gases. And just to hit that point one more time, all right, your building energy use, the materials that you select, and the transportation involved is closely tied to greenhouse gas emissions, which is tied to global warming. Now, of those different ways that you as an architect can affect these greenhouse gases, remember there was energy use, building materials use, and transportation. Which one is the most important to target? What's the highest priority? It turns out it's building energy use. So take a look at this chart of global greenhouse gas emissions by sector. All right. And you'll see that energy use is a solid 3/4. All right, it produces 3/4 of the greenhouse gas emissions total. And then narrow it down. We've got down here energy use in buildings, 17.5. You can see that that is a large chunk of this big red pie. All right, we can have a large effect on the process of global warming just by eco-design in our buildings. Okay, now you know that you want to design a climate responsive building. But there are so many different design strategies, so many sustainable design strategies out there. How do you choose? All right, and it turns out, this is why we're studying climate right now, that climate is going to set your design priorities. A building designed for its specific climate will be more energy efficient. So when you're designing for a specific building, you're going to gather that climate data and you can learn about your particular building site. But in order to study sustainable design, as a whole here, we're going to simplify and divide the United States into climate regions or zones. And the particular ones that we're going to use here are cool, temperate, hot, arid, it's a dry heat, right? And hot, humid. And each climate region within those 4 categories is going to have unique design priorities. And therefore, those design priorities will suggest appropriate design strategies. What kinds of design strategies are there? How can your architecture respond to the climate? We can separate them into 2 major categories, and one is passive strategies and the other is active strategies. And you're going to learn a lot more about the specifics of these strategies in the next section of your course. All right, but right now let's just learn the difference. So passive strategies are those that use tools and methods that are centuries old. They're usually non-mechanical approaches. They're simpler. They're more reliable because there's no moving parts. All right, and they're usually less expensive. Passive strategies can be thought of as your first line of attack in your quest for energy efficiency. Active strategies, on the other hand, are a way of reducing your building's energy requirements through active technologies. All right, so, and that usually involves the equipment in a building. All right. And then you have to meet any remaining energy needs through local and renewable power generation. All right, so generating power on site. Active strategies are usually more advanced technology. There's moving parts. And you can't really get to net zero energy or carbon neutral using passive strategies only. You have to use a combination of the two if you're aiming to hit those particular goals. All right, so we just made the connection in this lecture between climate and sustainable design. Thanks, everyone.